Welcome back to Calculus 1. We're looking at exercise number 2. We're using limit laws, tables, and continuity. Our solution is negative 2/9. Our first task is to find the limit of this function using numerical calculation and guesswork. So what they want you to do is generate a table of values, and that table of values will go ahead and we'll use that to try to determine the limiting value. So what I'm going to do is I want to look at x values that are close to negative 1. And I want to look for a trend. So I'm going to go from both the left and the right side. So let's come in from the left side first. What that means is that here is negative 1, and I want to start using values that are closer and closer to negative 1 from the left side. So that would be x and f of x. We'll call this guy inside here f of x. And so let's start picking some values that are close to negative 1 on the left side of it, so over here. So let's go negative 1.1, negative 1.01, and negative 1.001. And so what we're going to do is we're going to take each of these and we're going to plug them into this function. So I'm going to go ahead and pause and grab those numbers here for you. So here are the values that I obtained on the calculator, and I went up to 4 decimal places. But notice that it looks like the trend is getting closer and closer to the following. So we would say the limit as x approaches negative 1 from the left side of that function that's equal to negative 0.2 repeating is what it looks like. Okay, now that's coming in from the left side. So now let's look at coming in from the right side. So again, we'll make a table. Let me write down right side above this. Okay, now if we're coming in from the right side, we could go from like 1.1, which is somewhere over here, to 1.01 to 1.001. Now, I just arbitrarily picked these. You could pick other values, but you want to keep getting closer and closer to the value of negative 1. Whoops. That's right, negative 1. I need to change those. So negative 1, we could go negative 0.9. That's pretty close to negative 1. Negative 0.99, that's even closer. And negative 0.999. So again, I'm going to pause here. I'm going to go calculate these guys, plug these into my calculator. And so you can see from what I've done, it looks like my values are again approaching negative 0.2 repeating. So we would say that the limit as x approaches negative 1 from the right side is the same thing. So overall, we can take these two pieces, this guy up here and this guy down here, and we can combine them to sit at the overall limit as x approaches negative 1 of 2x over 4x squared plus 5 is equal to negative 0.2 repeating, which is negative 2/9. Okay. So doing this out here, this is not perfect. This is a little bit of guesswork here, because although it looks like my tables are leading us into that direction, it's not a good justification, right? It doesn't prove anything. It just gives us an idea of what we think the behavior of the function is. So now let's go ahead and take a look at using the basic properties of limits. So Now these properties have all been proven before by individuals, and we will go through with epsilon delta proofs and discuss these. Hopefully at some point in this course we'll be able to do that. So how are we going to use these basic properties that we've learned in this section? Well, we're going to try to evaluate the following. Now the first thing we got to look here is to see, does this -1 make the numerator, well, actually, does it make the denominator 0? And the answer here is no, it doesn't. So in a minute we're going to go ahead and we're going to use some replacements, and that's going to be a key point, is that this does not make the denominator 0 and leave the numerator to be some other value. So what we can do is we can split these guys up, and we can say, well, this is the limit as x approaches -1 of 2x over the limit as x approaches -1 of 4x squared plus 5. So I've used this quotient property, and the reason I can use that is because this limit of the denominator is not 0. If it is 0, you can't use this. So since this guy, the limit down here, is not 0, let's go ahead and compute these. This limit right here, this is the limit as x approaches -1 of x multiplied by 2. And actually, let me even write it out better. I'll write it out like this. And this is our product property for limits. We can split these guys up. And on the denominator, I can use the sum property to split these guys up. And actually, let me use both the sum and the product. I'll use the product down here and the sum in between. This is a little bit time consuming when you gotta go ahead and write all this stuff out, but we only do it for one section or two, so you just have to bear with it. Okay, so we used, not only did I use the product here, but I used the sum between these guys. Now this is the constant rule, so the limit as x approaches -1 of a constant is just that constant. The limit as x approaches -1 of the identity function is equal to the value that we're approaching for the limit. Here, this is going to give me 4 by the constant times -1 for the identity times another -1 for the identity plus 5 for the constant. So that'll be -2 over 4 times 1 plus 5 is 9. And notice that that is the same value that I got up here. Okay, so that's good. That reassures us that we've done something right. Had those not matched up, then we have an issue. We gotta go back and check it. So the last one asks us to use continuity. And this is the one that you like the most because it's the easiest to compute. So how does this work? So we want to know, what is the limit as x approaches -1 of 2x over 4x squared plus 5. Well, 2x, so f of x equaling 2x over 4x squared plus 5. This right here is a rational function. And rational functions are continuous. And since rational functions are continuous, it means the limits of the function. So the idea of a function being continuous is that if a function is continuous, the limit as x approaches x naught of f of x is actually equal to the function evaluated at x naught. So this right here means that the limit, this right here, instead of x naught, we're using -1. Right? So all we have to do is evaluate this guy. So the limit of this is equal, if this guy's here is f of x, the limits of f of x is equal to f at -1, which is just 2 times -1 over 4 times -1 squared plus 5, which is -2 over 9 as well. So you've got those three different ways. We've got the first way is making tables and doing a little bit of guesswork. The second way is by using the limit laws. The third way is by realizing that rational functions are continuous and then using the property of a continuous function by saying that the limit at the point is the function evaluated at that point.